both of them. Okay. So, so let's go to your Eviews. As I mentioned to you, it's a very simple, what is it, software. But when I look at your, what is it, your textbook, many of the exercises using the lab are actually applying the Stata. But it's okay, let's just get exposed with the basic software. So you can have any version, doesn't matter, because both they all will do the same function. Okay, you can see that this is my Eviews 12. You may get the latest one, it's fine as well. Okay, so I'm opening it. So I will just close this first. Okay. Okay, so apart from Eviews, you know that we're gonna have many other software. Well, you can also have SPSS if you are dealing with the primary data. If let's say you are dealing with the secondary data, normally people are gonna use Eviews or Stata as well, or perhaps the R. But for the R, it is not really recommended for you guys, because if you are so into the programming, then you can use the R. Okay. And we also have Smart PLS. This is the case if, let's say, your data is not really numerical or number. If, let's say, you want to analyze what we call, what is it? Qualitative data, like gender, all this kind of what we call dummy variable. So dummy variable, normally it is good if you want to use Smart PLS. So PLS stands for partial least square. You guys are learning OLS, which is ordinary least square. Okay, so okay, so now I think I already opened my Eviews. Okay, make sure that you guys are also opening yours. Okay, so you can have your what do we call your slide side by side if you want to look at the steps. Okay, maybe I put, where is it, here. Okay, so just double click your install Eviews. Okay, normally we will click to the file if you want to open your dataset. If let's say you have been opening your dataset quite sometimes, not really quite sometimes, just when you have opened it once, they will appear somewhere at the bottom. Okay, in this case, I open the data for housing price. I also open the data for a few other things. So if let's say you have opened it, they will be here. Okay, so you just click on whatever data that you have opened if you want to look at them. But if let's say in your case, this will be empty because you haven't opened anything. Okay, so when you click file, you will stop until exit. Okay, what you're going to do is that if you look at my instruction here, when you click file, just go to open. Okay, so you want to click foreign data as work file because you are actually importing the data which is not within the Eviews, because if let's say the Eviews are already familiar with the data, they will put it here. But now it is something, for example, some new data. Okay, click on it. So it will direct you to whatever data you want to find. Okay, in my case, let me see, where did I save it? Maybe under my desktop. Okay, maybe under your class. Okay, so house data. Okay, this is just the example. You're gonna create your own data set as well. Double click on it. So you will click next, whatever. So normally what I will do, I will just click finish. Okay. So you wanna link imported series or not? It's up to you. Normally I will say yes, or doesn't matter. Both are okay. Okay, you will get this. So once you imported the data, you will see something like this. Is it fine if let's say I open both sided, or you just want to see the whole thing? Can you see, well, can you see my screen clearly? Should be fine, right?
Yes.
Okay. Okay. So next, okay. So this is these are actually your data set. your variables. So you have to know that, okay, sometimes, where is the Excel? In your Excel, let me just give you the example. Where is it? Under, did I open? Okay. Okay, this is just the example. Sometimes in your Excel, you have a few page. For example, the first page, second page, third page, and so on. So for the Eviews, you cannot have this kind of thing, or else it will get confused. Okay, so you have to make sure that if, let's say, you want to import your Excel into your Eviews, you only have one page. Okay, you shouldn't have so many pages. Okay, so that's the thing. Okay, next. Okay, so now, if you want to run your OLS, you can go to, so there are only two buttons that you may want to click. First is quick. So quick, and then you go to, where is it? Where should we go? Estimate equation. Remember, OLS is meant to estimate your equation. Okay, so here are the box that you want to type your equation. So how you want to type your equation? First, you have to put your dependent variable, and then your constant, and then you can see here your C1 is actually the beta naught, your estimation, your coefficient, estimated coefficient. This is your constant. This is your second beta, or we call it beta 1, and your independent variable. Or you're going to have other variables. This is how you want to put it in this box. Okay, you can type one by one. Okay, so the methods, remember, as I mentioned to you in class, there are many methods actually if you want to estimate your equation. What we are learning now for this class is just least square method, or what we call ordinary. It's just a simple one. Okay, but if you click on this, you have two-stage least square. Okay, well, this is the case if, let's say, you have two equation, and in first equation, basically, basically the second equation affecting the first equation. That's why you're going to use two-stage least square. So this is actually very common depending on your relationships of your variable. Okay, it's very less likely people are going to use OLS, but many commonly people going to use two-stage least square, going to use GMM, generalized methods of moment. So well, Arch is normally for time series. Co-integration is normally for time series. Binary is not really for time series. Binary is depending on the, what we call, the measurements of your data. So have you heard about binary? Do you know what is binary? No idea.
1010.
Yes. So if your dependent variable is binary, if your dependent is actually 0 or 1, 0 and 1, so you're going to use what we call logit, probit, or extreme values. Okay. Because in our case for OLS, our dependent variables are number. You can have 1, 2, whatever, or decimal point. But if your dependent is actually 0 and 1, you have to use this binary stuff. You also have ordered. So for binary, for example, your dependent is male or female, 0 or 1. But if you have ordered, for example, your what you call dependent is actually 1, 2, 3. For example, you have bachelor, you have master, you have PhD. You have three level. Means that they are ordered, they are in rank. They have the lowest, middle, and highest. So again, how you want to use the method, it depends on the nature of your variables, nature of your, how you measure your variable. So there are actually many which will not be covered here. Okay, so just OLS. So sample, this is not 1400 something, this is sample number 1 until 427. So here is, it says that you have about 427 data. Okay, so you can type whatever your equation here and then click OK. So this is the what we call the instruction here. But normally for me, well, I rarely use Eviews. But when I need to use it, I don't use the first steps. I use the second one. What I did is that, okay, click control in your, what we call digit button. Okay, you click, press on the control, you start clicking the dependent, which is your price. Remember, this is the data for the housing price. Click the price and whatever variables, whatever independent variable later on. So perhaps I want to click size, I want to click times, maybe distance. There are many other variables. I just want to click this variable. Okay, so I have selected them. So the first variable I selected should be dependent, followed by independent. Now that you can see I have selected them, so right click, remember the instruction said right click. So open as equation. So basically the variable, the equation has been typed for you. So this is for those who are very lazy, you don't really want to type whatever variable, you just click and then they already type for you and click OK. Then you have your estimation ready for you. Okay, so far so good? Okay.
Yes.
Yes,
Okay.
madam.
Okay, so now I will move to the next slide. Okay, so this is how you want to estimate your equation. Okay, so before that, let me make it, okay, here is the command. Normally for those who want to use Eviews, you don't really want to type the command. Commands here means that you want to type the instruction so that the Eviews can actually give you the result, can run the result. For those normally who want to use command, mostly they're going to use Stata. But for Eviews, you just want to click the, what we call the items here. Okay, so I will just ignore the commands. Because commands is, you have to remember what are the command for each of the regression. But for your case, you just want to run OLS. So I don't think it is important for you to learn the command. Okay, so ignore the commands. So this is your estimation. You can see your result. Dependent variable is the price of your house price, house. And this is the method, this square. So for the Eviews, they will tell the dates of you running this result then and the time. So this will tell me if, let's say, you are doing your assignment last minute, because I will see your dates, I will see the time, when did you do it. Your sample from 1 until 427. So you have, this is the observation. Okay. You can see some of you may be asking, why do you have, you already mentioned you have sample 1, number 1 until 427, but then you still put include observation, your end 427. Okay. In my case, okay, this data set is complete, means that there is no missing data. If you have missing data, they will put here sample 1 until 427, but include observation, your observation, they will exclude the missing. So you will see 400 or 415 only. So it shows that not all data are actually complete. Okay, but in my case, they are all complete. That's why you can see the same number. Okay. Okay, so the variables here refer to your independent variable. So you can see the C. C refers to your what? C is, what is C?
Constant.
Constant, yes. C is your constant. Okay, now, so this is the coefficient of your estimation. Remember, when you put your coefficient, is also called your betas. Okay, beta head. This is the standard error that you make when you are trying to estimate your coefficient. This is the t statistic. Okay, so that later on you know which variables are significant or not significant. But well, if you want to use t statistic, you have to have some calculation. But many econometrician, they will look at the probability, the p-value. Okay, remember p-value 5% and less shows that it is statistically significant. Okay, so you can tell from here there are two variables that are statistically significant: size and time. Okay, it shows that the larger the size of the house, the higher the price of the house. Okay, and so on. So you have the probability of p-value to tell the significance of the variables, and then you will see your R square, your adjusted R square or your R bar square, and then you also will see the F statistic to show the contributions of all the variables and the probability of even though you can see that, where is it? Distance is not significant in affecting the price, but in total, if you can see the F statistic will tell the total contributions of all these variable to the changes in the dependent variable. In total, basically, their contributions are statistically significant. Okay, and you also have some information that you will be using when you want to check your classical assumption, AIC, SIC, we call it, um, as well as the Bain Watson. We will look at it later. Okay, when we are going to the chapter of each chapter, like hetero, multiple, and so on. Okay, so let's see how you want to test for classical assumption. Remember, you don't want to violate the assumption, or else your estimation will not become blue. Okay, so I'm assuming that you should know what is blue. Okay, let's start with normality test. Remember, you have 7 assumption. Normality is an optional assumption. But if you have this normality, so you will have the blue. Okay, so how you want to test it? Okay, these are the instruction. Okay, so you have to click. Remember, the first button you have to click is quick, so that you can estimate if you want to do the quick. But if you want to just click from the variable, it's up to you. It is quicker. Okay, second button, you want to go to view. Okay, so under view, not so many. So you go to residual diagnostic. Okay, and here normality, you can see here that you have histogram or normality test. Click on it. Okay, you can actually make it larger. It's up to you. Okay, so you will see, well, as if like, I don't know, can you see like your diagram look like normal? Do you know what is normal? Anyone? Do you know what is normal? Remember I mentioned in class, normal means that your diagram look like a bell curve shape. So if you look at here, as if like it is normal, but is it really normal? So how you want to check it? So go to the probability. Where's the probability? Probability is down here, 0.000. It is very significant. What does it mean? So this is the hypothesis. H null, error term is normally distributed. H1, error term is not normally distributed. So probability value, which is this one, if you can see my cursor, probability value less than 0.05 means that you have to reject H naught. Error term is normal. You don't want to reject H naught. If you reject H naught, means that your error term is not normally distributed. Remember, we want our error term to be normally distributed. So in this case, probability shouldn't be significant. You don't want this to be significant. If it is significant, it is not normal. Even though you look at our diagram look like normal, but because probability is significant, so you reject error term is not normal distributed. So your error term is basically not normally distributed. Okay. So remember, this is an optional assumption. You can have it or you may not have it. Okay. So how do you want to fix this? If let's say, oh my God, my distribution is not normal, I will violate the assumptions of blue. So what happened if you don't want to violate the assumptions of blue? So the rule of thumb says, if let's say your distribution is not normal, you have to increase the sample size, because the more sample size you have, the shape will be looking like normal. So keep increasing the sample size so that it will become normal. Okay, so done. The second one, multicollinearity. Okay, so well, let me delete this. Or does it want to be deleted? Hmm. Okay, yes. Okay, you can click, let me see. Because I make it larger just now, no? So you can click on this small cross button. Delete untitled equation, yes. Because you don't want to use, you don't want to see that. Okay. So now let's check for the multicollinearity again. This is your previous equation, previous variable. You can take other variable. It's up to you. Let's assume that I want to use the same variable. Okay, I have selected this. Remember, when you want to select it, select the dependent followed by independent, and then right click, open, as equation. So you just click OK. You will have this what we call estimation. So go to the same thing. This is like the what we call the instruction. Go to view. If let's say multicollinearity, you have to check for coefficient diagnostic. Okay, so where is the multico? VIF. This is what we call variance inflation factor. So click on it. So you will have the result. So there are many other things. You want to see the centered VIF. Okay, the rule of thumb for having multi-co, the VIF value, the VIF value should, well, depends. Some people said that the value of 4 indicates that you already have a multi-co issue, but some allow until 8, some allow until 10. Okay, so it's up to you. In our case, what is the value? It's actually below than 4. It means that we don't have any multicollinearity issue. Why is that? Because each of the variable are measuring different things. That's why they are not related with each other. Remember, if you have multi-co issue, some variables, when they change, the other variable will follow. Okay, if let's say size increase, time may also increase. If size increase, time may decrease. So as if like times is following size. Okay, in this case, these three variables are measuring different things. So you don't have the problem, the issues of multicollinearity. Okay, if let's say you have the problems of multi-co issue, what you gonna do? How to address it? So you will see this thing in details once we touch on the multi-co chapter. So this is just a brief solution or suggestion. You can transform the model by taking log. Perhaps if let's say you have under here the centered VIF is actually I don't know 12, 13. So you may want to put log in size or log in time. Okay, you may want to transform your model by putting log or transform the variable. For example, you think that, well, time and size are measuring the same thing. So just take one variable and combine these to become one. Or simply delete the variable. Okay? So, how you want to transform the variable? Let's say. Yes. As equation. Okay? But perhaps you want to put mm, this is your dependent, right? Okay, perhaps you want to put log here. Log, put it in a bracket. Or maybe you want to put log in time as well. Who knows? We don't have any multi-core here, but just in case, if you have multi-core, you want to put the log. Okay, so click OK. So you're gonna have some log function. Let's see, do they have a multi-core? We don't have the multi-core in the first place, but just want to see how does it look like. Coefficient and then VIF. Oh, you don't have any because these variables are measuring different things. But sometimes some variables are very similar, so you may want to put logs to see how does it change. Okay. Okay, so this is multi-core. Let's move to the next one. So far, so good, right? Okay. So this is the problems of heteroscedasticity. Well, I will not explain what is this hetero multi-core and so on because you have seen this before, right? So for today's workshop, I just want to tell you how you want to utilize the Eviews. Okay, so let's delete this first. Yes. Okay, before you want to run this hetero test, you have to actually run the estimation. Okay, you can simply click views, run it first. Okay, open, run as equation, click OK. Okay, then click view. So this is what? This is hetero, right? So hetero should be residual, your error term. So hetero. So everything are here. You have hetero, you have serial correlation, remember? Okay, so click on it. These are the various steps, various tests if you want to test for your hetero problem. In your course, we will be using only Bruce Pagan Godfrey. Okay, it's already by default. So just click OK. Then you have the result. Okay, so you can see that we have the probability, right? So what is the hypothesis? When you have the probability, you have to check what is the hypothesis. Hypothesis said that H0, no hetero. H1, that is a hetero problem. So if let's say H0 is no hetero, you don't want your result to be significant. In this case, your result is significant. If it is significant, means that you reject your H0. Your H1 means you have a hetero problem. Okay? So in this case, you have an hetero issues because I'm only selecting a few variables. Of course, you are not including many other things. It's okay. So how to address this problem? By looking at this probability, if you can see my cursor, oh my god, this is significant. You have a hetero problem. Okay? So what you're gonna do? Now, you can transform your data, convert them into log form if you want to. Okay? You may want to put weighted least square. You want to attach weight into the variable. Okay, we will look at this detail in the chapter once we go to the chapter. Or you may want to use hack test. Okay, so let's try to apply the first one. Okay, and the third one. Okay, so where is the first one? Mm-hmm. Delete this first. Yes. Open equation. So let's put log. Does it change? Sometimes it may not change. That's why they give you a few options. You may want to use this, you may want to use this, depends. So you put log to the size, you put log to the time. Let's see, does it change? Again, this is your estimation. And so it's like a try and error. You may get it right, you may get it wrong. I mean, uh, that's why you have to include all the relevant variables. If let's say some variables are not included, they may go to your error term, and this error term will actually be high and uh, will show that as if like you have a hetero issue. So let me put this log. Once everything are included in your model, you may not have this problem. Okay, let's assume that these are the only variable. Okay, but then we have a hetero problem. So you put the log. This is one of the solution. Click OK. You got this. So let's try to check the hetero issues. Hetero is residual. Hetero. Okay. Oh, still significance because you didn't include many other relevant variables. That's why you have the problem. But just in case if you have included everything, but you still have the hetero, try to put log. Okay. Then what else? If let's say you have put the log, still you have the hetero. Let's try the hack test. So what you're gonna do? Click the estimates. Estimates is somewhere here. Okay, if you can see my cursor. And then go to the option button. So this is the option. And what's next? This is your covariance method. Okay, you don't use ordinary least square. You use hack or new VWS. And then just click OK. So once you click OK, so basically you have actually forced this equation to solve the issue of hetero. So once you click OK, now it is free from hetero issue. This is the last resort. If you have tried other things, you have included all the relevant, you have included transform the variables into log, transform into their, not necessarily log, into their correct functional form, put square or whatever that you think that it is the right functional form, you still have the hetero issue, then the last resort is using hack test. Okay? Next. Serial correlation. Okay. Delete. Okay, now you have to run this first, remember, as the equation. Then go to view. Under residual serial code. Okay, by default, they include 2 leg. Well, this is fine. Just click OK. Okay, now you have to see the probability. Well, you don't want the probability to be significant. What is the hypothesis? H null, no serial correlation. So you don't want to have serial correlation. H1, there is serial correlation. At the moment, it is significance means that you have a serial correlation because you rejected H null. Okay, so how to address it? Again, you can add more variables, but what else? Serial correlation. Okay, I didn't include it. You can have a correct functional form. Correct functional form and other things. Okay. The details will be explained in the chapter of serial correlation. Okay, so this is for serial correlation. Next, what else? This is the last one. Thought that I already put something. Okay, so one of the assumption is you don't want to have a specification error. You want to make sure that you have included all the relevant variable. But now, how do we want to test whether we have the issue of specification error? Okay, so let me delete this. Delete, yes. Okay, run it first. Open equation. Okay, now go to the view. And then where should we go now? Second last, stability diagnostic. We want to make sure that our equations are stable or not. Okay, so Ramsey reset test. This will tell you whether you have correctly specified your models or not. Click on it. Well, by default is 1. Just click OK. So you will have this result. So there are many other things here. Your main concern is just the probability for the first 3. Your T stats, F stats, and likelihood ratio. So I did put here, you want to see the probability for T, F, and likelihood ratio. They shouldn't be significant. In our case, they are not significant. Means that your models are correctly specified. This is good. Even though we didn't really include everything, but somehow it turned out to be good. Well, this is just by random. Okay, sometimes you will see that these 3 are significant, 0.000 something, 0.05, but at the moment they are not significant, which is good. Means that you don't have specification error. So how to address the same thing? You can add log, add new variables, or drop the variables and so on. Okay, once we go to the chapter, we will learn the details. What should we do next? Okay, so yep, I think these are about your Eviews. Any question? They are very simple, right? Any question? Anyone? Are they all clear?
Whether for your review, what the version that you use, because I use the student lab, but it does not have the option like open a equation.
Really? You should have it. Yes. Okay. So if you click open, what do you have? What are the options that you have?
Like it just take the open as multiple window. Like it does not have other option.
Because in previously, when I taught my students using Eviews 10, uh, they still have this kind of option. So I'm not sure in the Econs lab, what kind of version. Is it less than 10?
Um, I used to use 12 version, but maybe the student edition is limit.
I don't think so, because this is actually a free version. It's not even the purchase one. This is like what we call the pirate version. Okay,
Oh,
so
because
it should be.
I directly download from the website, the
Oh, really?
student line edition.
Mm. Well, in that case, I'm not sure. That's why I said I cannot really check on your laptop because I'm not with you. But if you don't have that option, just go to the quick, like the first one. Remember, go to the quick, and they should have this button, of course, and then estimate equation. and then you will see this. But you have to do it one by one. It will take some time. I mean, well, you want to make it quick, right? But you still have the option. Okay?
Okay, I see. Thank you.
Okay. So anything else you want to ask? You want to see how, because, okay, where is your textbook? This one? Chapter 1. Okay. Surprisingly, your textbook is actually using Stata. That's why I was like, when I check on the lab, they are using Stata and so on. But very, like, I mean, some example, I think out of 10 example from the textbook, only 1 or 2 are using Eviews. Even here, they are telling you how the Stata work, how it look like. Okay. And some data set are actually, if you use Stata, you can actually extract from the Stata. But somehow for the EVs, we don't have it. Okay. Well, the Stata is here and is even user friendly for me, but it's not really like, let me double click on it. Okay. The same thing. This is also the pirate version. Okay. It's just that what we call you have to really use the command. Okay, you cannot really simply run by clicking here and there. You can, but well, there are so many. If you want to find them, it is time consuming to find which one. This is binary, so you have to check because there are so many. So normally for Stata, we just write the command and they will give the answer straight. But you have to memorize the command. The problem, you guys, you cannot even memorize your theory. So if you use the Stata, you have additional info that you have to memorize. That's why I was thinking, well, you cannot use it. Okay, so let's just give you the taste of Stata. Okay, where is it? This is my other data. Where is your data on Eviews? Let me see.
Madam, I think I know why it happened, madam.
Why it
Because
happened? Why?
yeah, as like some of my friends also said they don't have some sort of options when they click the right click. I think maybe because they download straight from the website.
Oh,
Because I did download straight from the website at first,
uh-huh.
but then I installed the one that you gave in the iTag link. The one that
I
require
did.
email address and so on.
Oh, really?
Yeah. So I think maybe the one that you sent is we all need to use that one.
Hmm. Okay, I cannot tell because I cannot see that in front of me. But you can try and error and check. Okay, which one is working for you? But it's just a shortcut one. Okay. Let me see. I wanna show how the data may look like. But let me see what kind of data do I have it here. Which data? Oh, let's see the house price data. House price. Where is it? Open. Where is my open? Open with this. Control all. Control copy. Okay. So let me see data. Not this one. Yes. You can just simply paste into it. Okay. So where is the variable? Oh yeah. So for the Stata, you have to click the command. For example, OLS, you have to put regression, reg. So you have to memorize each of the methods, each of the command. If you want to check for hetero, if you want to find from the button, it will take some time. You just have to memorize it, and I think you will be having a hard time doing that. So rec. So here, these are all the variables that you have. So they have a different look, right? So where is the price? So you just click on the price. It will go into the command. So normally the first variables is your dependent. It works for all types of software. So you have price, you have what else? Distance. What else did we choose just now? Time and size. Okay, and then just enter. They will give you the result straight away. But you have to memorize the command. So for us, because this is something that we always use, so we will use Stata because it's very, very quick. Okay, so let's see the difference in terms of the result. Where is your Eviews? Oh, I didn't. So let's go to the price, control, what else? Distance, time, size. Open. See, this really will take some time, right? So you have to go to equations and then okay. For the Stata, you just click regression, click the variables, you will see the result straight away. That's what so you can see that the distance negative, well, the same thing. The result will give you exactly the same thing. It's just that you're going to have different way of looking at it. Okay, so the p-value is somewhere in the middle here, this one. But what we call Eviews is on the right side, on the end. Okay, so they are all very similar. It's just that for those who want to be very quick, you will go for the Stata. Yeah, depends. Okay, and then what else? What else? Oh, the textbook. Textbook. Where is it? Textbook. So this is well, what you have in your textbook. I can just ignore this since you have learned in the workshop about how to use Eviews. Let's practice it. Okay, if you don't practice it, you may not know. Okay, so exercise. So there are two types of lab in the textbook. The first in chapter 2, the third in the chapter 3. But chapter 3, you can only use it if you use Stata because the data are actually from Stata. I don't know if let's say you can get the data from somewhere. Let me see. Page 89. Page 89. This is what I told you that when I click 89, it will appear straight away. But it doesn't work in the class. Okay, so it is actually lab 2. They give me the data from, because they ask you to do step by step. Step one, you have to do this, step 2. So given the same data, I want to see whether you also produce the same result, right? So the data is actually coming from here. But in Stata, when I click on it, it's not really functioning. So I mean, it directed me to this, but I don't know where should I go from here. Okay, if some of you can actually extract the data from this, we can actually do the exercise. But if cannot, then just go to this one, lab 1, page number 63. 63. Okay, this is lab 1. It's good that if we can do the lab 2, but I don't know how to get the data using those links, unless you're going to use the Stata. Okay? Okay, so let's see. So from lab 1, okay, this is the first one, first lab, because before this we haven't covered the Eviews. That's why you may not know how to use it. But now, since you have seen how the Eviews function, so let's just do the lab exercise. Okay, so you will collect a data set and calculate regression coefficient and the goodness of fit measure. Okay. So what you're going to collect? Your dependent variable is weight and independent is height. So just ask 5 students. This is just a simple exercise. So you just ask your friends, 5 friends, and just record the data for their height and weight. Remember, you have seen this kind of equation before? Okay. So you're going to have this kind of thing. Okay. 5 students, remember? And then try to solve step 2, calculate the statistics. Okay. What does the means to you? Run the regression. Okay. So in this case, because you only have height and weight, so you only have a simple regression. You don't have other things. If you want to put other things, it's fine. It's good as well. So you can also have multiple regression. In this case, just 2. You can have more. Okay, remember you are dealing with 5 observation. And then interpret your coefficient, interpret your R. Okay, now you add male. Or basically you add male in the first place. Okay, you have 2. Okay, so that's the exercise. Okay, so basically in this exercise, you have 2 variables. Male as the dummy, and another one is what? What is another independent variable? Height or weight? Height. Of course, the higher you are, it will affect your weight. So height. So you can have one more variable added into your equation. And let's see how you get the result. Okay? Any other question? Any other question?
No.
Is it clear? Is it clear? Let me stop sharing, stop recording. Okay? Because